Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on accounts merge. We are going to use disjoint set union data structure to solve this. If you are unaware of this data structure, please go through some YouTube video or online and please learn about this data structure. Or I will be creating a video soon on this data structure and will attach it to the link. Okay. Let's jump into the problem statement, understand it, and start solving. So last time we have solved time-based key value store. You can find it in the list. Let's start with accounts merge. Okay, given a list of accounts where each element's account I is a list of strings where the first element accounts I0 is a name and the rest of the elements are email representing emails of the account. Okay. Now we would like to merge these accounts. Two accounts definitely belong to the same person if there is some common emails to both accounts. Note that even if two accounts have the same name, they may belong to different people, as people could have the same name, right? A person can have any number of accounts initially, but all of their accounts definitely have the same name. After merging the accounts, return the accounts in the following format. The first element of each account is the name. The rest of the elements are email in sorted order. The accounts themselves can be returned in any order. Okay. So let's understand this from the example. We are given accounts John, that is the first one would be the name, and then rest of them are the email that are associated with this name. We can say John Smith at mail.com, John New York at mail.com. Similarly, we have one more John with John Smith at mail.com and John 00 at mail.com. We see John Smith and John Smith is common in this case, right? So that would mean that all these three email IDs, John Smith is one, John Smith New York and John 00 belong to the same person, that is John. Similarly, Mary at mail.com, again John at John Bravo at mail.com. So that is a separate person, John, who has only one email ID, John Bravo. So the output is first John name, and then John 00, John New York, and John Smith. The three emails as we discussed, right? Similarly, we have Mary and then Mary's email. Then another John and that respective email ID of that John. Right? So all we have to do is we have to find out the email IDs, right? And we have to traverse through them. We have to find out if they belong to the same account, and we have to return the name and all the corresponding email IDs of that account, right? Now this problem can be solved in many ways. You can use the brute force attack as well, but it would be very time consuming problem, right? Because you would have to search through everything. You would have to compare each email ID with each of the email IDs provided in other accounts just to match if any of the email ID matches, right? Or a better approach would be that we could use disjoint union set, right? Okay, let me provide you a very small okay, let me provide you something to understand it. Okay, draw on line. Let's see, start drawing. Okay, so what happens in disjoint union set is you have to consider in this case each email ID is a node. Okay, and right now each node, let's say we have one node, then we have another node, then we have another node, and then we have another node, and similarly one more, let's say. And let's consider this first example. So we have John and then we have one email ID, johnsmith@gmail.com. Okay, so let's say this is John Smith. We'll call this is John Smith email ID. Or where is the undo button? Okay, we'll say this is the first email ID. Okay, let's assume this first email ID, second email ID, third email ID, fourth email ID, 5th and 6th. Okay, now the first email ID and second, third, fourth, fifth, and one more for 6th, right? So we created email IDs, we created separate individual nodes for all the email IDs, right? And right now all of them are disjoint. That means they are not attached to anyone, they point to themselves and they are the parent of themselves, right? Now what we'll do is we'll check that John Smith is attached with John New York, right? So 1 and 2 are attached, so we'll attach them. Okay, now let's say we mark 1 is the parent. So 1 is the parent of itself and 1 is also the parent of 2, right? Next we see John Smith and John 00 are also attached. That is email 3 in this case. I know John Smith and John Smith is same email ID, but in this case we consider 3. Okay, now let's say so 3 and 4th are attached. We'll mark them. 3 is the parent of 4, right? Or let's consider it this way, that 1 is parent of 2. In next one we found John Smith and John 00, so we'll make 1 is already available, so we'll not keep 3, we'll remove 3. The 4th is John 00 and that is attached to John Smith, and 1 is also John Smith, so we'll attach this one also with John Smith and we'll mark 1 as its parent, right? Now similarly we have Mary, that is not attached with anything, so Mary will be its own parent, right? Similarly we have John Bravo, that is its own parent, right? Okay, now this way if we get any email ID, let's say we get the second email ID and we check if it is its own parent, that would mean it's the disjoint set, right? Otherwise we'll check 2 and let's say we are checking for node 2 and node 4, do they belong to the same person? If both of them have the same parent, in this case 1 is their parent, right? If both of them have the same parent, that means they belong to the same person, and in this case the same account, right? So this is what overall how the DSU works. You can actually go through some videos on internet to understand how the DSU works, but overall this is the generic explanation, right? So we are going to create separate nodes, then we are going to attach them to one single parent, that way we'll know that which email IDs are attached to one single email ID, and then in the end we'll merge all the accounts related to one person, that is John. Okay, with this let's start solving, and with that it will be much clearer. I would suggest the best approach would be that you first go through at least one video on disjoint sets to understand this problem. We can solve it in numerous ways, but the reason we are picking, or the reason I am picking disjoint set union, is because it is efficient, plus it's new data structure for everyone to cover in this series, right? So let's start. Okay, so we'll say we'll first put email to, we'll put a map. Okay, map for emails and indexes. Okay, we'll put all the emails with indexes 0, 1, 2, 3 like this. We'll say map string integer email index is equal to new hash map. Okay, now we need another map for a name to email relationship, right? So we'll say map string, not name to email, rather email to name, email to name. So John Smith will be attached to John, John New York will be attached to John. Okay, this way. String email to name is equal to new hash map. Okay, now We'll initialize one parent array for the DSU. Okay, so parent array for the DSU, int parent is equal to new int, initialize with 1000, since we are assuming not more than this nodes would be present in the question. Total account length is 1000. Okay, now we'll initialize them as well. So for int I is equal to 0, I is less than 1000, I plus plus. One second, account length is 1000, 10, 30. Yeah, let's add another 0, 10,000. Okay, I plus plus. Let's initialize all the values with the same index I as only. Okay, because initially each node is its own parent, right? Until we have found the relationship between the nodes, each node was its own parent, right? So we are saying parent of first node is first node itself. Let me comment it. Parent of each node is the node itself. Okay, now let's traverse through our accounts. We'll initialize one id equal to 0 for list of string account from accounts. Now first element in the account list is the name, right? String name is equal to account.get 0, right? Next would be the set of email IDs. So we will check if it is not included in our email already. So email index contains, or it should not contain, right? It should not contain. We have the not equal to sign. So if email index contains key, which we have to check for the email also, right? We are not checking for the email as of now. Okay, we'll remove this. We cannot do this way. We need to process all the emails in this list. So we'll create another for loop. For int I is equal to 1, we'll start from 1 since the first one was the name. I is less than account dot size I plus plus. Okay, now we'll check string current email is equal to account dot get I. Now if which map is it? Email index contains key. We'll check for current email. So if our email index already contains this email or not. Okay, if it does not contain, we'll put it in the email. So we'll say email index dot put current email and the ID, right? So ID would be ID plus plus. Similarly, email to name map dot put, we'll say current email and the name, right? That's it. So with this we are entering all the names in the email to name list with the each email associated with the name. So email name. Similarly, we are maintaining another map which is containing the email IDs and IDs associated with them. But for their first occurrence, we'll have the ID. When they are occurring the next time, we'll not add them, right? Now we'll check. We'll create the union with the first email and the current email. Okay, so we'll say union the union the first email and the current email. Okay, so for this I will create one union method as well. So first let's calculate find out the first email. Int first email id would be email index. We have to call this first email index, or we can call idx. First email index would be email index dot get. We want to find out for the first email. Account dot get 1, right? Similarly, we'll find out for the current one as well. Current email index is equal to email index dot get current email, right? Why we are doing this is so that we can find out that 2 is also associated with 1, and similarly 4 is also associated with 1. Okay, yeah, so with this we need to create a union method. Let's first create a union method. Okay, we have this ending here. We'll create a union method. Private void union. We provide int x, int y, int parent, and we also need to create a find method. So what the find method does is it traverses through in the DSU data structure. What find method does is it traverses through the arrays, through the nodes, and for each node it checks whether it is parent of itself or not. Until it reaches itself as the parent, it keep moving towards its parent. So let's say if we have one node, and then second, then third, and then fourth, and fourth has this as parent, this one has this one as parent, and then this one has this one as parent, right? It starts from fourth node, it checks, move to third, it checks for third, it moves to second, it checks for second, it moves to first, and at first it is the parent of itself, right? And in the end it updates for all of them as the main root node as the parent. Okay, I know this is not a good drawing, but you can follow some video for the DSU data structure, but that's how the find would work. So we need to create a find method also. Okay, so I'll say find operation with path compression. Path compression is the technique with which all the nodes would be pointing to its parent root node, right? So we'll say private int find, we'll pass int x, we need to pass the parent array as well. Okay, and we can say int p is equal to parent x. Okay, now we'll check while p is not equal to parent p. So until we reach the root node where the node is parent of itself, we'll keep going to the parent. So we can go to the parent with parent of p is equal to parent of p, right? And p is equal to parent of p. In the end we'll say return p. That's it. Okay, so from the union what we are going to do is we are going to say parent of we are going to combine the union. So we, in this case, for two email IDs 2 and 4, we are going to say parent for 2 and parent for 4 is the same, right? So we'll say parent for, we'll find for x and parent is equal to find y and parent. That's it. Okay, so we'll call the union method here. We'll say union, we'll find first email idx, current email index and parent, right? That's it. Now we have created the union. So in the end, this union is already formed where everything is attached, and we have a disjoint connected node of graphs where 1 and 2 are attached, 4 is attached to 1, 2 is attached to 1, 5 and 6 are disjoint, right? But now we want to find out all those email IDs and group them together. So how will we do that? So once we come out of the for loop, we'll say, so the grouping emails that belong, grouping emails that belong, grouping emails together. Okay, we'll say map integer and tree set. Why would we use tree set, right? Why do we need to use a tree set? Because when we'll do a search, it is easier to do a search with the sorted email IDs. With tree set, we already store the email IDs in the sorted manner. So rather than searching them again for constructing our final answer, that is the result, we'll store them in the sorted manner using the tree set. So we'll say map of integer and tree set string, okay, groups is equal to new hash map. Okay, so for string email from email index dot keyset, we'll say int root is equal to find, we'll pass email index dot get email and parent. This is, we need to close, okay, parent. That's it. Then we'll just merge them together. Groups dot compute, compute if absent root x, we'll use the lambda notation, will perform x new tree set if it is not available, dot add email. That's it. Okay, similarly now we want to construct our answer to add it to one list of string, right, to form the results. So we'll say list of string result is equal to new, where is, okay, not the comment section, no, new array list. Okay, for now we'll go through the tree set, not to the tree set but to our group. For tree set format, string group from groups dot values, there is something that we are missing. We'll calculate for each of the values, okay, for each of the values, the group value. I know even my solution is little fuzzy. This was actually very difficult for me as well. I have opted for easier approach, but the time complexity was really bad, so I had to go through several other solutions to understand and then implement this. So please mind my explanation in this video, and in case you have a better approach, please do let me know. Okay, so we'll traverse through the set of groups. We'll find the first list, that is list of string account, okay, new array list. Okay, now for each account we have the name, we need the name and the emails. So account dot add, we'll add email to name dot get group dot first. So we'll find out the name, and then similarly account dot add all groups, so it will add rest of the list. Okay, so first one will add the first name, that would be the name of the user. The rest will add all the rest of the elements, that will be the email IDs. And simply then we can say result dot add account. That's it. Yeah, and in the end we can return the result. Okay. Okay, let's run and test it. So before trying to understand this, please go through the 37. Please go through the what's wrong. We are expecting something. So if it is not absent, okay. Yeah, please go through the videos on disjoint union set. We are missing something. String line 17, too many typos. Yeah, okay. As I mentioned, even I have understood this solution from someone else's solution and then tried to replicate it. Okay, so I would suggest that you go through the videos on disjoint set DSU first, and then come to this solution to actually understand the solution for this problem statement. Oh, too many typos today. INTEGR integer. Let's see if it runs. Otherwise I might have to create the video all over again. Bad return type in lambda expression. Why the bad return type? Compute if absent, we are saying root x is equal to x new tree set, and then add email. What have we missed? This email closes here. No tree set, we need one more closer. Okay, let's see. Okay, this is the problem. Yeah, I was already sure. Oh, we still have more. Email I think something is wrong today. Okay, email to name dot get group dot first. Okay, finally let's submit. Okay, so yeah, in the end it beats 98.86% of the users. So in the end, it's a really long video for this tricky problem. I would again suggest that you go understand the DSU first, then come back to the solution and then understand it. And please let me know in the comments if this solution is still very complicated and not required. I'll upload the one with the simpler approach. I was going to upload that one first, but then it's a good idea to understand the disjoint set as well, right? Okay, yeah, that's all from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.